Hunger is hidden in the face of this child. The number of people who have suffered from hunger in 2020 was between 720 to 811 million. You probably have eaten your third meal of the day. But do you know that more than 30% of the world's population doesn't have regular access to adequate food?
To put that in perspective, 3 out of 10 people don't have enough food to meet their daily nutritional needs.
The solution is simple yet elusive. Grow food on a larger scale.
Is it even possible? Our solution to this problem is to equip smallholder farmers with a low-cost smart irrigation system. The 600 million smallholder farmers who work on less than 2 hectares of land are estimated to produce 28 to 31% of the world's total crop production and 30 to 34% of the world's food supply. Acknowledging their contributions at a full scale would mean that they could produce about 1/3 of the world's food supply.
The problem is, smallholder farmers are financially and technologically burdened. These burdens are carried over to their crops.
Smallholder farmers still heavily rely on traditional monitoring for irrigation frequency, where a PVC pipe was buried into the soil with an inch or 2 of its length left protruding to the ground. When a visible amount of water is collected in the PVC, smallholder farmers will not water their crops. When it is dry, they will turn the irrigation valves to provide water. This is a hit-or-miss process because most of the farmers are just estimating the amount of water to supply. At this point, too much water was wasted that sums up to an increase in the production cost.
A good irrigation strategy is an important part of the cultivation process. If smallholder farmers know how to match the amount of water needed by their crops, their harvest yield will improve. Improving yield will provide a positive impact on domestic food stability.
Our humble solution is aligned with UNESCO's Sustainable Development Goal 2, Target 2.3 and 2.4. We would like to help smallholder farmers by utilizing our engineering knowledge to design and fabricate a low-cost, smart irrigation system that uses an Arduino-based microcontroller equipped with a soil moisture sensor.
The readings of the soil moisture sensor will trigger the switch connected to the 2 water valves that can be adapted to the existing water piping system. All connections are attached to a water flow sensor to automatically adjust the amount of water needed until the optimal soil moisture is obtained. This can prevent the effect of overwatering the crops. It can also improve water usage efficiency, which is covered under SDG 6, Clean Water and Sanitation, Target 6.4, and SDG 12, Responsible Consumption and Production, Target 12.2 and 12.3.
Based on our chemistry knowledge, we would also like to add a soil pH sensor to help smallholder farmers to determine proper acid-base balance. When the soil is too acidic or too basic, it affects soil fertility and plant root growth. It also causes improper development of the crop. Monitoring soil pH can also help smallholder farmers to understand soil quality and make an informed decision on reasonably applying fertilizers to their crops. To keep costs low and be energy efficient, the smart irrigation system is solar powered. This intent also aligns with SDG 7, Affordable and Clean Energy, Target 7.2.
We plan to fabricate 6 units for the initial trial and link all units to an IoT cloud to notify the smallholder farmers of the irrigation status. We will create a simple dashboard to help 6 neighboring farms to monitor real-time data. Sharing each other's data and good practices can help them to understand the quality of the soil in their geographical cluster.
To help us materialize our idea, we have conservatively calculated that we will need 40 USD to produce 1 unit of the low-cost smart irrigation system. This is 15-fold cheaper compared to a commercial soil moisture meter, water flow meter, and soil pH meter, which are sold separately. Our estimated project expense is 240 USD for 6 units. We are seeking collaborations from smallholder farmers, government institutions, industries, and other universities to try out our engineering idea.
I am Sean.
I'm Li Shuang.
And I'm Brendan.
We are biomedical engineering students,
And we are here to step up.
Our sustainable engineering idea may not be perfect, but in our little ways, we will always do our best to create a better tomorrow.
We are knocking on your generous hearts to join us in helping smallholder farmers to realize the full potential of their lands. Let's provide them with the capability of harvesting more crops for our growing global population.
Together, we can make a difference in people's lives and bring back the smile in the face of every child.